Hello and welcome to the fourth video for outcome 30.3 on set theory. For video 4, I'm going to make two short mini lessons. The first mini lesson is going to be all about creating and using Venn diagrams that have three data sets. So in terms of our main goal today, it is going to be to use sets to model and solve problems, again, using three data sets. So to begin, we are going to start by looking at what happens when we have three sets. We already have a formula that pertains to the principle of inclusion and exclusion for two sets. Remembering that that formula was the number that was in set A or in set B was what happened when we added up the first set, the elements in A. We added it to all of the elements in set B, and then subtracted off all the elements in A and B, the ones in which were overlapped. So when you have three sets, it is a very similar formula. We take all three of those sets and add them up, and then we do some subtraction of the overlaps. But something strange happens at the end, and I'm going to quickly illustrate why. So if I look at the number of elements that are in set S, I look at set S here, this blue one, and it is all the elements there. J plus G plus H plus I. If I then go to the number of elements in T, it is all of those elements here in the green. It is the F plus the I plus the H plus the E. And then if I look at the number of elements in C, that is this red one here. The D and the E and the G and the H. But again, there are parts that were overlapped, parts that I counted twice. And those are the ones that get subtracted off, which you can see there's the subtraction there. So the first subtraction is the intersection of S and T. So S and T is this part right here, and we did count those twice, the H and the I. The next intersection is the number that were in S and in C. So S and C was this part right here. So the G and the H, I did count twice. Similarly, for the number that are in T and C, this part right here, the E and the H got counted twice. Now, something should be kind of glaring at us, is that we did add these H's over here with the number in S and T and C. We then subtracted out the H's over here in our three intersections. Ultimately, we added H 3 times and subtracted off H 3 times. We've now totally lost H, which is why in the formula, we have to add it back in. That intersection of S and T and C being the middle, in this case it's H, needs to get added back in. So it's a really complicated formula when you look at it, but when you look at its pieces, it's not as difficult. And so what I'm going to do with you is an example using that formula. So it says, use the following clues to answer the question below. We have 28 children who have a dog, a cat, or a bird. So that is all kids. We're going to end up with 28 kids. 13 have a dog, 13 have a cat, and 13 have a bird. 4 have a dog and a cat only, so that intersection place. 3 have a dog and a bird only, so the second intersection. And the third intersection of 2 kids have a cat and a bird. No child has 2 of each type, so there's not any kid that has 2 dogs or 2 birds or 2 cats or something like that. So we need to figure out how many have a cat and a dog and a bird. Basically, that means that they have all 3. And then how many children have only 1. So to start this question off, I'm just going to make 3 intersecting circles. And I'm just going to label them. This bottom one I'm going to call dogs, and then cats, and then birds. And I'm going to start by just putting the 13 in the dog, and in the cat, and in the bird. Yes, I know I put them in a place where it's only dogs, or only birds, or only cats, but I can delete those off as I enter in more data. Alright, the next piece is that there are 4 children that have a dog and a cat only. So right there would be dog and cat only because the middle would also have a bird. There's 3 children that have a dog and a bird only. So dog and a bird only is right there. Because again, the middle would be all 3 animals. And then there's 2 that have a cat and a bird only. What we have no idea is, what is that middle number? And we're going to call that x. That is what we're going to try to figure out. So now I'm going to go ahead and try to start using the formula. So it told me that the number that were in A, or in B, or in C equals. I take the number that were in A, plus the number that are in B, plus the number that are in C. Just kind of making the vague formula. Then I subtract all the intersections, the number that were in A and B. Subtract off the number that were in A and C. Subtract off the number that were in B and C. And then add in the number that were in A and in B and in C. Now this question has dogs, cats, and birds. So instead of using A's, B's, and C's, I'm going to use the dogs and the cats and the birds. Oops, sorry. Just going to get it back onto the notes. Alright, so the number that have dogs, or cats, or birds equals the number that have a dog, plus the number that have a cat, plus the number that have a bird. Subtract off the number that have a dog and a cat. Subtract off the number that have a dog and a bird. Subtract off the number that have a bird and a cat. And then add back in the middle the number that have a dog and a cat and a bird. So this part right here, the number of dogs and cats and birds, they're all of them. And we know that there are 28 that have all 3. Now the number that had a dog were 13, plus the number that had a cat was 13, plus the number that had a bird was 13. Now I subtract off the number that have a dog and a cat. So if I go back up to my picture, my dog and cat intersection is this one right here. There's 4 that have it only, plus X amount that have all 3. I need to subtract that in total intersection. I got to subtract off the 4 and the X. So I got to subtract off the 4 plus the X. Subtract. Now I go to dogs and birds. Right, so I just carried that one and now I'm on the dogs and birds. So if I go back up, dogs and birds is this part right here. The 3 and the X. So I need to subtract off all of that, the 3 and the X. Now on to the birds and the cats. So that is this intersection right here. The birds and the cats. The 2 plus the X. And then I need to add the intersection in the middle, which was my X. So I have 28 equals 13 plus 13 plus 13 is 39. And now remember, when you subtract in brackets, you need to distribute that negative to everything that's in that bracket. So I'm going to subtract off a 4 and an X, a 3 and an X, a 2 and an X, and then I'm going to add that X back in. So remember, when we have letters and numbers together, we put numbers with numbers and letters with letters. So I'm going to have 39, subtract 4, subtract 3, subtract 2, which is 30. So 28 equals 30. Then, remember, whenever you have x's, just imagine there's an imaginary 1 in front. So negative 1, subtract 1, plus 1 is a negative 2x. And now I just got to solve for x by getting it by itself. Always start with the one that's not attached, so the 30. Do the opposite, which is to subtract 30. So 28 minus 30 is negative 2, equals negative 2x. Last step, divide by negative 2, and my x equals 1. So So that is the number of kids that have all three. There is one kid who's lucky enough to have all three. So how many have a cat and a bird and a dog? That is one kid. So if I go to my Venn diagram, this middle number here, where there is an X, it is a 1 now. So the last step of this problem is to figure out those 13s, because the 13 was not birds only, cats only, dogs only. So on this Venn diagram, for the birds, I have to take the 13 and subtract off the ones that also have birds and other animals. So the 2, and the 1, and the 3. And so that leaves me with 7 kids that have only a bird. Now if I go to the cat only section, there's 13 that had a cat, but 2 had a bird also, 1 had all 3, and 4 also had a dog. That leaves me with 6 that have simply a cat. Now I go to the dogs. That was 13. Subtract off the 3 that also had a bird, the 1 that had all 3, and subtract off the 4 that also had a cat. That leaves me with 5 that simply had a dog. So how many have only one pet? Well, there are 7 that have just a bird. There are 6 that have only a cat. And then there's 5 that have only a dog. So a grand total of 18 kids altogether that simply have 1. So in terms of practice number 4, the questions that have to do with this example, what you should try. So if you go to practice 4 in your textbook, you could try questions number 1, 3, 7, those 3 questions relate to what we just did. And the next video for Lesson 4 Part 2 will be on how to search using our set theory.